Hey guys, I'm going to review really quick back to the vector basics, and then we're going to do work. So remember that in linear combo or component form, vector V is AI plus BJ, where I is the horizontal unit vector and J is the vertical unit vector. So here we have vector V in yellow. Magnitude V is the length of vector V. If we drop a line here and create a right triangle, then we see that the horizontal component A is right there and the vertical component B is right there. Let's call theta this angle. So cosine of theta is adjacent over hypotenuse, and sine of theta is opposite over hypotenuse. If we isolate A and we isolate B, we end up with the following other form of writing a vector. And this takes into account, this is the way we write a vector with magnitude and direction angle. A is the same as magnitude V cosine theta. B is the same as magnitude V sine theta. So here we have the work definition. Work done by a force moving an object from A to B is given by the dot product of the force and the direction vector and the vector of the movement of that object from A to B. Okay? So we can look at the dot product two ways. The multiplication of the horizontal components of both vectors plus the multiplication of the vertical components of both vectors, or we called it A1 times A2 plus B1, plus B1 times B2. So we're back to this question. A child pulls a wagon along level ground by exerting a force of 20 pounds on a handle that makes an angle of 30 degrees with the horizontal. How much work is done pulling the wagon 150 feet? So we have the force and the direction at which that force is being applied. The magnitude of the force was given to be 20 pounds. The theta, the direction angle of that force, is 30 degrees. The magnitude or length at which we are pulling this item is 150 feet. The theta at which it is moving is 0 degrees. Why? Because it's moving along level ground. So this is this direction, where this guy is this direction. So our force is going 20 at 30 degrees. Our wagon is going 150 at 0 degrees, creating this image right here. So how much force is being done? How much work, is being done. Remember that work is the dot product of force and the AB and the direction at which that force is being applied. So if we actually did that, we would get work is equal to the magnitude of force cosine theta multiplied by the magnitude of AB cosine theta plus the magnitude of force sine theta times the magnitude of AB sine theta. All right? Now, if we fill stuff in here, cosine, we fill in 20 there, 30 here, 150, 0. We fill in 20 here, 30 there, 150, and 0. So sine of 0 is 0, which is why this disappears. Again, sine of 0 is 0, so this product is all going to zero out. Cosine of 0 is 1, so it simply becomes, let me move this out of the way for you. Oh, no, let's move that box. Come on, little guys. All right, it simply becomes magnitude of F, magnitude of AB, cosine of 30, because cosine of the level ground is 1, which he ended up staying up here. Cosine of the level ground is 1. So it's not cosine squared theta because the thetas are different. So it's cosine of 30 times cosine of 0, which is understood as a 1, so we didn't necessarily need to put it, but this is why. This explains why what happened. This also explains why work is a scalar, because a dot product is a scalar. Now we are multiplying a force, which is in pounds, to a direction which is in feet, so our units, once we do that dot product and see that this zeroes out and that becomes 1, and it's just these three guys multiplying, our units are feet pounds. Yeah, so 2598 feet-pounds, the work done is approximately 2,598 foot-pounds. Hopefully that was clear, and you will be able to do more of those on your own. So 6-7, it was fun to visualize a lot of things with you guys. This is what you should be able to do now that you have worked through 6-7. Find the dot product of two vectors, find the angle between two vectors, use the dot product to determine if two vectors are orthogonal. Find the projection of a vector onto another, express a vector as the sum of two orthogonals, and compute work. Now we practice. Now we get show ready, and that's what block day is going to be all about. Thanks for playing.